Hey folks, welcome back to this video of Frank Physics. This is Frank and today I'll be talking about vectors. As you already know that there are two types of quantities in physics, scalars and vectors. Scalar are the quantities which are represented just by a number and we also call it as magnitude. Okay, when we talk about the vectors, we're dealing with not only the numbers but also the direction. So as you can see that you're going to figure out that the magnitude happens to be the common thing between scalars and the vectors. So today over here we'll be just talking about the vectors and how to deal with the vectors. Okay, for just simplicity, I'm going to divide this video into two parts. Okay, in the first part I'll be talking about the vectors which are parallel, and the other part of the video will be related to non-parallel vectors. When I say parallel vectors, I mean to say that the vectors can have the same direction or they can have the opposite direction, but they have to be parallel over each other. That's an important thing, as you can see in those examples. When I talk about the non-parallel vectors, I want the vectors to be in any of the directions possible. So they can have an acute angle, they can be perpendicular, they can make an obtuse angle between them. So anything other than 0 will be non-parallel vectors. So let's get started with the parallel vectors. Okay, so parallel vectors. Just imagine a body being acted upon by two different forces. One, say, to my right with a force of 10 Newton, and there is another force acting towards the left with a magnitude of, say, 9 Newton. Okay, so the vectors acting on the body are 10 Newton and the other is 9 Newton. Okay, in this situation, if the vectors are in opposite direction, I would have to subtract. They will gonna give me a final vector which is 1 Newton to my right. Okay, that's one example. I'm going to give you the other example. There is a block of wood or maybe a stone being pulled by two people from the other side. Let me just write down the values of force acting towards my right to be 100 Newton. And there is another vector of the force acting on the block towards my left, 75 Newton or something. Okay, so what will be the final product or final value of the force that is acting on this particular block? It would be simply subtraction, as I told you, because the vectors are arranged in different order. As you can see, this vector is acting towards my right, this vector is acting towards my left. So as I told you earlier in the previous example, they have to be subtracted. 100 Newton minus 75 Newton, and that is 25 Newton. So this block would be acted upon by a force of 25 Newton towards my right. When I have two different forces acting on the body, and when we talk about combining effect of those particular forces, okay, I'm gonna call the combined effect to be a resultant. So over here in this case, 25 Newton would be called as resultant. That is the product of original two vectors, which were 100 and 75 Newton. In this particular case, this 1 Newton will be called as the resultant force, and the original ones, that is 9 and 10 Newton, will be called as component vectors. Like over here in this second example, 75 and 100 Newtons will be called as component vectors, and 25 would be of course resultant. The resultant vector will be the result of two or maybe more than two vectors acting upon a body simultaneously. And there is one more thing that I need to tell you. What if I have two parallel vectors acting on a body and they are in the same direction, 4 Newton and 4 Newton? We're going to be dealing with it by adding them together. Like when they are opposite each other, we subtract. When they are in the direction of each other, we're going to combine them, we're going to add. So this block is as if acted upon by a resultant vector of 8 Newton to my right. So I'll just write a summary on the other page. If I want to summarize the the mathematics of parallel vectors, so if the vectors are in the same direction, they have to be added to get the resultant vector. And if they are in the opposite direction, they have to be subtracted to get the resultant vector. So that's all about the parallel vectors that you have to remember. Okay, here we start with the second part of our video, and that would be the non-parallel vectors. And I bet mathematics of non-parallel vectors is not very easy as it was in the case of parallel vectors of addition and subtraction. It's a little beyond that. So let's see. Let me introduce how exactly we're going to be dealing with the non-parallel vectors while we want to find out the resultant of them. We're going to be using this 5 different steps to find the resultant out. That's 1, 2, 3. We got the 4th, and the last one is 5th. Okay, let's get started with the first one. I will try to give an example at the same time. So scale the vectors down. That's the very first step that you have to do. Now this is applicable only in the situation where you have the vectors which are of very big size. I mean, when I say big size, it's impossible for them to put on the paper. So I'm going to give an example of this sort. Let's see. Okay, I consider an object in the shape of ball be acted upon by 2 different forces. One of the forces is acting towards the east. Force is the vector that I'm dealing with. So there is a 25 Newton of force acting towards east in my body. It is being acted upon by another force which is acting towards the north, and well, it's again of 25 Newton. So you got it, right? As you can see, the number 25 centimeters, it's impossible for us to draw this on a paper, right? So we're going to be scaling it down. So when I say scaling it down, it means that when I draw 1 centimeter of a line on my paper, how much of the vector it should correspond to? 1 centimeter should correspond to 5 Newton on the paper. Okay, so that's my first step. Okay, the second step is to arrange vectors at adjacent sides of parallelogram. Well, when I say parallelogram, sometimes it can be as easy as a cube or maybe a rectangle. So, sometimes it can be as easy as that. Okay. So, if I want to do that in this example, it will look something like this. So, that's my 5 centimeter. That corresponds to 25 Newton. Okay. So, that's my second step. Right, the third step is to complete the parallelogram. Okay, so if the angle is 90 degrees, you're going to have a cube or rectangle. So in that case, you have to complete the cube or rectangle. So in my case, I'm going to be completing the cube, it seems, because both the sides are equal. That's my cube. And it happens to be the third step. Oh, I forgot to number them. So arranging them in adjacent side, it's the second step. Completing the cube in this case is third step. And let's talk about the fourth one. Okay, draw the diagonal beginning from the starting point of component vectors. So starting point, let me just say what starting point is we're talking about. Okay, that's my starting point, and these two are, as you already must be knowing, that these two are component vectors, and I need to draw a diagonal of this parallelogram, which happens to be cube, which begins from this point. So let me just precisely draw that particular diagonal. Starts from here, goes up to the other end. That's my diagonal, and that also happens to be the fourth step of my construction. This line, the diagonal that you drew, is called as the resultant vector. So 5 Newton in the side, north side, 5 Newton on the east side will give you a resultant force acting towards this, somewhere in northeast side. Okay, so the diagonal, okay, the basic thing is the diagonal is the resultant vector. So what's the fifth point? I mean, we already done with, right? Not yet. Fifth point is, or rather fifth step is to scale the resultant up. That means I'm going to measure this length, the length of this diagonal. Okay, and if I measure it, it turns out to be 7.1 or something. In precisely, it will be 7.07, and when I measure it using scale, it turns out to be 7.1. So, well, if I say I had earlier said that my 1 centimeter corresponds to 5 Newton, obviously 7.1 centimeter correspond to 35 Newton in the given direction, the north is. So that's my last step. And let me just number it. That's how it is. We got the 5 different steps. We also followed one example based on it. Okay. We're gonna be doing a more real example of such type of vectors. Behold for them.